Today we'll be looking at the PCV system on this 2013 Chevrolet Malibu with the 2.5 liter inline four. Over here on All Data, we have the system description pulled up in operation. Here's our intake. We're receiving fresh air. It's going through the valve number 1, where the clean air is being inlet into the crankcase, and it's going to wash away or help carry out all the bad crankcase fumes and gases such as the hydrocarbons and the carbon monoxide. This valve number 3 right here is just in case of excessive blow-by. In the event that there's a lot of crankcase pressure, this PCV valve, this is what this is located, number 3, will open up and allow the crankcase gases to come back through the intake and back through port number 1. If we remove this section of the intake, we can observe the shared port for the PCV valve and the inlet valve. This would be the number 3, the PCV, and number 1, the inlet, located right here, number 1, number 3. We can take these out and listen. They are valved, and they're one-way valves, so this one only allows air in, while this PCV valve only allows excessive crankcase pressures back into this shared plenum and through port number 1 again.
So as our engine is running here and that crankcase pressure starts to build up, it is going to get vented right here off the vacuum from the brake booster and go over here to the intake manifold to be fed in with this clean air, and then back into the motor to be burnt and sent to the catalytic converter. So here we are going to be performing our dollar bill test with this piece of paper here. So basically we are going to start up the car, take this oil fill cap off, and then place this piece of paper on top of that. You should see a slight suction from the PCV. So if you want to start the car, as you can see from our test here on the oil fill cap, the dollar bill that we had was getting no suction when it should have very little suction there, and it's actually showing the blow-by of the motor, which is not getting vented to the intake because of this PCV valve here not opening up and distributing that excessive pressure. So while we were looking here at our PCV system on this Malibu, we noticed this here, and we were trying to figure out what it was. It is actually a vacuum pump here for part of our PCV system and our brake booster, and how it feeds off the exhaust cam, spins here, and then feeds the vacuum. So here we are on our Suzuki Verona, going to be looking at the EGR system, and it is a linear EGR, and here's our 5-pin connector, and we're going to be taking a look at it on the car. So here is our EGR system on the Suzuki, and here's our 5-pin connector. As you can see, we're on that pin 1, seeing 14 volts as our power. So we are now tapped into the second pin there, and that, as you can see, is our 5-volt VREF.
Now we're tapped into the middle pin of the EGR, number 3, and we're getting a steady signal voltage of 0.7 volts. So the EGR valve is not barely open even at all, if any, and that's our...
Okay, so we are now here on pin 4, which is our potentiometer ground, and we are reading 0 volts, which looks good.
And lastly, we're on pin 5 of the 5-pin connector for the EGR, and we have 14 volts, which makes sense due to the fact that this is low side driven, and there's full potential through the solenoid of 14 volts. So as we ground this meter and we tap into here, we're also grounding the voltage, so we're receiving the full 14 volts from the power terminal 1. So the operation of the EGR system is to effectively lower the NOx emissions as we're driving down the road. So the EGR valve can only be used when the engine is warm operating temperatures and above idle speed. Almost always in the condition of cruising, like on the highway or a steady speed, the EGR valve will effectively allow burnt up exhaust gases to go into the combustion chamber and effectively take up displacement of the engine, so we're burning less fuel and we are causing less NOx emissions.